I will be doing question number 18 on page 588. Now in this question, we have determined there are three different lengths. So you have the length 0.1 meters, 0.2 meters, and 0.4 meters. And this question is asking to find the maximum and minimum current that this block can carry. And you're given it is 6 volts. And you have the equation volts equals current times resistance. And since we're trying to find the current, let's just rearrange this so it becomes I equals V over R. And from previous knowledge, we know that R can also be written as the constant P resistivity times the length over area. Now, length over area could be made with any combination of these three. So there's three different possibilities you could have. Length over area, the first one would be 0.1 over 0.2 times 0.4. The second one would be 0.4 over 0.2 times 0.1. And the third one would be 0.2 over 0.1 times 0.4. And when you calculate these out, this is going to be 1.25 meters, 20 meters, and 5 meters. Now, when we look at the equation I equals V over R, in order to maximize the current, we need the minimum resistance, which means that in the equation R equals PL over A, you want this L over A to be the smallest amount. And in this case, that would be 1.25. So your equation for this one, the current of the maximum, will be the voltage, 6 volts, over the constant 1.7 times 10 to the negative 8th resistivity for copper, which you can find in a table, multiplied by 1.25 meters, which is the L over A, and that'll give you 2.8 times 10 to the 8th amps. And that's your maximum. Your minimum would just be the exact opposite. So the current of the minimum would mean that in order to minimize this, you want this to be the maximum, which means that in the equation R equals PL over A, you want the L over A to be the largest. So that would be 20 meters. So then your equation would be 6 over 1.7 times 10 to the negative 8th resistivity constant, multiplied by 20 meters. And that'll give you 1.8 times 10 to the 7th amps.